Hello, my viewers. Today we'll be talking about the graphical representation of Hooke's law with this chart. You and I know that any material that after being extorted by a force and it increases in length is an elastic material. So whenever force or load is added to an elastic material, there's going to be extension. So to show this is the graph of load. When you add the load to this material now, there's going to be extension. So in this particular graph, we have many variables here to show the extension of an elastic material. Here is P, we call it the proportionality limit, and this is the elastic limit. So the elastic limit is this region, is the region whereby the elastic material, if force is applied or load is applied, it experiences an extension. Then after the extension, normal shape or size. Now after that elastic, the end point is the plastic region size again. So what we call that area, yellow, this area now is the yield point. So when the material gets to this yield point, when force is applied, it cannot return to its elastic, it cannot return to its normal shape or size again when the force is removed. But if it is elastic region, so when you apply a force or a load on this particular material, it will be found and it's compassed to when you apply a force within here or a load within here, the material is bound to be extended. There's going to be extension of the length of that material. Then when the force is removed, the material will come back to its normal size and shape again. Then when you add a force that is higher than the strength of that material, the force will yield and get to this point. And when it yields and gets to this point, when you remove that force, it will never return back to its normal size or shape again. Then when it goes beyond the yielding point, that bound to what breaking point. That is to say that material will tear into pieces because the force added to it is higher than its strength and it can never bear such force again. It's what it called. From 0 to E is called the elastic region. Then from E to B, from E here to B is called the plastic region. It is called the plastic region in the sense that when you remove the force, after applying the force on that elastic material, it will not come back to its normal size or shape again. That is to show you that the force added to that material is bigger and higher than the strength of material. That is exactly what will make the material to yield. So within this region now, it is called a plastic region because the material is no longer an elastic material again. Because it cannot come back after a lot of force or load, it can't come back to its normal size or shape again. So we call that region plastic region. That is from E to B, they are known as plastic region. Now, after which you get to what's called B. The B is the breaking point, and that breaking point is as a result of excess force or load being applied on that material. If the material can never be able to bear, if the strength of the material